Okay, like I said, I'm going to give you a video on strategy and how to do harder proofs, or to walk you through some of the basic proofs that you may have trouble with. So this kind of a strategy is called reverse engineering. I sort of made that up. It's not actually gone over anything. But so the last video we had Carmina Burana, which is a little too epic. And so I think we're just going to play some electric counterpoint for you this time. Okay. To start off with, let's have a proof. Let's try to show that not A entails if not B, then not A or B. Right, and so to do reverse engineering, instead of starting from the beginning like we would before, right, we would go line 1, not A is the premise, right, and then we would move forward and try to figure out what we needed. But in reverse engineering, what you actually do is look at your conclusion and you try to think about what you would need to make the conclusion, which is very, very helpful. So if you see here, the conclusion is a conditional, and to make a conditional, you would use the rule of arrow introduction, right? And so if you knew that the arrow introduction rule produces conditionals, it makes the conditionals, you could say that in order to make this formula, you would apply this rule. And then, of course, you'd have to refer to 2 lines in order to use this rule. And the 2 lines that you would refer to, the first, right, would be the antecedent, and the antecedent must be assumed. And so you always have to have an assumption to use this rule, right? And that assumption should match the antecedent. Next, you would need the consequent, right? And so you would need negation A or B. So basically, this kind of thinking says that I can make this formula if I had the assumption not B and the formula negation A or B. So with that said, how do you get assumption not B? Simple, right? You just assume not B. So we know that we sort of can get that as a freebie. And likewise, with this, well, not as a freebie, that we can't get that as a freebie. We have to think about how we're going to produce this formula. So if you see here, this is a negation, and so this is a negated formula. And so to produce a negation, right, we need to apply the rule of negation introduction, right? The introduction rules create the kind of formula with which it's named after. So negation introduction will produce a negation. And so how do we use negation introduction, right? We need 2 things. We need to refer to 2 lines. Of course, the first line is the assumption of its opposite, which is A or B. We have to assume the opposite because if you want to produce a negated sentence that looks like this, right, you're going to have to use something that looks like this without the assumption. So we assume the opposite. Okay, next we're going to need a lambda, right? And the lambda is just a contradiction that's been signaled. Where's the book? Okay, so here it is. If we look back to the rules, right, to use negation introduction, we need the lambda and the assumption, whatever that is. And once we have the assumption and the lambda, we can use negation introduction to produce a negated sentence. Okay, so now that sort of gets us to another step. Here, how do we get the assumption of A or B? Just like we got the assumption for not B. We just assume it. That's one of the rules that we can do. So here, these are two easy steps that we can have. Next up, how do we get a contradiction? Right, and so a contradiction is going to look something like P on a line and then not P on a line, right? And that would form a contradiction with which we could signal to make a lambda. So when we have a contradiction, the rule we're going to use to create the lambda is negation elimination. And so the two lines would have to look like P and not P. So here's where the strategy gets a little fishy, right? In order to create a contradiction, we have to have something in its opposite. So we've got a couple of candidates for, what makes the contradiction. So we have A or B, right? We have not A and we have not B. So this is the stuff we sort of have to work with. So if you want to pause and sort of, if you got to the assumptions and you want to write the assumptions out just so you have it, that would work as well. And here a note is going to match the rule with which it's going to attach to. Right. And so we might think that we can get the negation from negation A paired with A, or negation B paired with B. Right? And so those are the sort of two paths we can take. But actually, this is a little complicated because we would use the disjunction A or B to produce our lambda, right? So if you can see that, you sort of have to write a little side note, A or B, right? And then with A, you get to assume that, and with B, you get to assume that, and use or elimination to produce the contradiction. But these two, of course, would produce the contradiction, but you'll have to use or elimination to get rid of the assumptions of A and B. So right now, you sort of have an idea of what you need to do from this, but more importantly, it'll give you a lot of direction. So now, since we have A or B, which is the disjunction, right, we can use the or elimination rule to try to work with the disjunction. So in order to work with the disjunction, we have to assume each of its sides. So we assume A, right, for or elimination. And I'm just going to go step by step instead of assuming everything first. Right? And if we assume A, we can create the contradiction immediately because not A is our premise. And so we can write down the lambda, and the lambda is true, right? Or the lambda is created by the contradiction between 1 and 4. Negation elimination. And it's true because of line 1, which depends on 1, and 4, which depends on 4. So that's 1 and 4. Then on line 6, right, we've gotten our lambda, but we don't move on yet because, like the little note here says, we have to use or elimination to get rid of this assumption. So that means we have to assume the other side and also try to create the lambda again. Okay, so given that B also creates a contradiction immediately from 2 and 6, right, that's very useful. All right. Okay, on 8 we have the lambda that's been created from either side of the disjunction. So in this case, remember that if you can get to a target formula, which is just a formula that can be got from either side of the disjunction, you can repeat that formula, the target formula, and use OR elimination to get rid of the two assumptions. So, yeah. Okay, and so how you use OR elimination is you cite the original disjunction, the first assumption, the target formula, right? The second assumption of the second disjunct, and the second time you got to the same target formula, and that's OR elimination, right? So again, that's the original disjunction, the assumption that matches the left-hand disjunct, the target formula which you derived from assuming the disjunct, and then the assumption of the second disjunct, right? And then the second sort of second time you derived your target formula. And then here, to calculate the dependency numbers, right, we have to add up all of the dependency numbers from 3, 4, 5, 6, and 7. Okay, but remember that we have to discharge 4 and 6. So the dependency numbers should be just 1, 2, and 3, because 3 comes from 3, 4 will come from 1 and 4, 6 comes from 5, comes from 1 and 4, I'm sorry. 6 comes from 6 but gets discharged, and 7 comes from 2, so it's 1, 2, and 3. Okay, so once we get our contradiction, right, we said we can use that contradiction to negate A or B, which would produce not A or, not A or B, right? And so not A or B from 3 and 8. Negation introduction. Okay, and that would be from line 3 and 8, but this is a discharging rule, right? And so here the note says discharge this assumption when you use it with negation introduction. So we use this line 3 with negation introduction, so it should be discharged, and so it's 1 and 2. And on line 10, right, we said that if we had negation B and the negation of A or B, we can put that together with conditional introduction to create our conclusion. So that's what we're going to do now. Right? And so if not B, then not A or B. Whoops, didn't really match up, but it's okay. This comes from line 2 and line 9, arrow introduction. Now the dependency number should come from 2 and 9, but because 2 is an assumption that gets used with a discharging rule, right, we discharge it, which means we leave it out of the dependency number, so the dependency number should just be 1. So this is sort of how you use the reverse engineering strategy as a sort of a map or a guideline on where you should go. So a couple of notes. This is a strategy, and like all strategies, sometimes it works better and sometimes it breaks down. So as you can see over here, it sort of breaks down a little bit, and it might get a little confusing. But if you want to just sort of stop at the contradiction, or just think about how you could get the contradiction, what the possibilities are, you could do that. But sometimes you can do the reverse engineering strategy and have a complete proof from that. Or rather, not a complete proof, but all the steps you would need to create the proof. Here we got the major steps, and from there, right, the second note is sort of, you can work forwards after you create a sort of a map for your end project. And so you could sort of move forward a little bit, and then move backwards a little bit, so that you fill in your proof. And for longer proofs and more difficult proofs, that might be a good idea. Okay, I hope that helps. I'll be back with more strategy in a little bit.